MANTA is a distributed auto-machine learning platform built on the Matrix Mainnet. It hosts a range of auto-machine learning applications and their deployment systems, which are accelerated using the latest distributed storage technologies. It uses auto-machine learning network search algorithms to locate a high-precision, low-latency deep model, and the search process is also accelerated using distributed computing technologies. There are two types of participants in the MANTA ecosystem: computing power providers, also known as miners, and algorithm trainers, also known as scientists. The miners in the MANTA ecosystem can lease out their spare computing power to scientists who need this computing power to carry out machine learning, and the scientists will in turn need to pay the miners a certain amount of man based on their computing power consumption. Currently, MANTA is mainly employed in machine vision related AI algorithm training. In the future, we'll be looking to develop AI generated content features by adding relevant algorithms and language models.
Here are some system requirements for deploying MANTA as a miner. For CPU, you need at least an Intel Xeon series with a base frequency of 2.0 GHz and at least 8 cores. Then for GPU, you need at minimum NVIDIA Pascal with a 12 GB memory. Both internal and external bandwidth should be no less than 10 gigabits per second. Then we need a solid-state drive of at minimum 700 GB. 500 gigs of these would be for storing mainnet data, and 200 of these would be for storing training logs and models. Finally, for network configuration, we need an address that is in the format as shown here. The IP part should be an address that is accessible through public network. The next part is downloading datasets. Now, the datasets we're going to use here are images available to the public on ImageNet. It is common to use these images for visual recognition related machine learning, and our miners will need to have these datasets ready before they can perform the visual recognition related tasks and algorithms of our target users. In the same way, if MANTA launches AI generated content in the future, miners will also need to download language or artwork datasets before they can run related algorithms. For image recognition, we need to download the two datasets linked separately here, one for training and one for validation. So we copy the two links one after another into our browser to start downloading. Depending on the speed of your internet, the downloading process may take anywhere from 1 to several days to finish. So just directly cut to the part where we have finished downloading, and the result is the two zipped files here. Now we unzip these two files and we get two folders, one for training and one for validation. In the training folder, we'll see a further 1000 zip files, and in the validation folder, we'll see 50,000 different images. Now we go back to the training folder and rename it to train, and we open the train folder and unzip its all 1000 different zip files. Wait for the process to finish, and after we have got all the 1000 unzipped folders, we can delete all the original zipped files. Remember, all the 1000 folders each represent one category of images for image recognition, so do not randomly change the name of the folder. Now we deal with the validation folder. First, rename it to val, and then open the terminal on your computer, and in the window that pops up, enter cd and 1 spacebar, and then drag the whole val folder into the window and hit the enter key. So what this process will do is to categorize the 50,000 different images in the validation folder into a further 1,000 subfolders to match the format of the training folder. Now, as a final step, create an ImageNet folder and drag in both the training folder and the validation folder. To download all the 6 files needed for parallax estimation, copy the link here and paste it in the browser. Once in the page, scroll to the bottom, then do exactly what we do here in the video. Click all the 6 files needed for parallax estimation. Click every single one of them to start downloading. As you can see, 4 of these files are BitTorrent files, so you would need to have a downloading tool that can download BitTorrent files. What you see here in the video is we are using our own tool, but feel free to use anything that works like uTorrent, BitSpirit, etc. Now finally, we have all the datasets that we need for both image recognition and parallax estimation. Let's organize all of these into one folder. As you can see, we have created a folder that we name MNT, under which the 2 datasets that we need for image recognition are all under this one folder that we have named ImageNet. Then, under the MNT folder, we have a second folder that we have named SceneFlow, which is where we're going to put all of the datasets that we will use for parallax estimation. We organized the 6 datasets into 3 subfolders. Now, if we go back to the web page where we downloaded the datasets, we can see that they fall into 3 categories as marked out here. And the 3 subfolders that we create under SceneFlow are named accordingly. Place the datasets each in its own category, and we have all the datasets ready for both image recognition and parallax estimation.
Before you can use your miner as a node to run AI services for MANTA, there's one more step we have to do. You have to install MANTA on your local computer. Download the installation program through the link on the bottom of the screen, then decompress the package using this command. Now, let's wait for the process to finish. Afterwards, we delete the cache file. And we also delete the original zip package. Now we enter the dist.automl directory through this command. And we install the required Python library for our project. Lastly, we enter this command to launch the operation of MANTA services on our miner. Take down the external URL that appears on the bottom of the screen. You will have one that's different from ours, but take it down, we'll need it for the next step. Now that your mining node is ready to run MANTA services, you still need to link it to a wallet in order to receive your rewards. We are going to assume here that you already have a MAN wallet, or you know how to create a new one for your mining node. But in case if you need more help, feel free to pause this part of the video and follow each step we did. Or check out one of those more detailed video guides we have released previously. Next, you need to send your wallet information to us so that we can credit your mining rewards to your wallet. Go to the address linked here. This is an encryptor that will help you convert your wallet address into an encrypted message. Also, create a new password for your wallet and click the encrypt button down below. This will also help you convert your password into another encrypted message. Next, draft an email to MANTA miners@matrix.io and title the email miner information. In the email, write down 4 types of information in exactly the same order as shown here. These are your wallet address, the encrypted password in the previous step, and the encrypted wallet address of the previous step. Last but not least, you need to provide your external URL. If you don't remember what your external URL is, remember we obtained that while installing MANTA on your mining machine. Once you have all 4 information, send them to us. Lastly, to complete the linking process, use this command here to open your wallet info. Copy and paste your encrypted wallet address inside the wallet info. Once done, you can relaunch your mining node. As a miner, you may check your mining rewards in one of 2 ways. Method number 1, go to tom.matrix.io, copy and paste your wallet address in the search box, and under Transactions, click MANTA to view all of your profits from MANTA. Method number 2, go to this address linked here and select Dashboard in the menu. The dashboard shows the mining profits and other information of all the participating nodes. Just select any node in the list to check. This is the end of the tutorial for miners. Now you're ready to lease out computing power from your machine to scientists for profit. For scientists, MANTA is a platform for you to take advantage of the computing power provided by miners to train your AI models and build your own AI services. In the next part, we'll introduce you to the back-end module, the front-end module, as well as the project manager tool. The back-end module is for scientists to train AI models. Go to the address linked here and select a type for the training task you wish to start. Then choose a GPU node for training, create a name for the task, choose a model, and select one dataset. Next, set some training parameters, which include batch size and learning rate. Finally, click Run to start training. The front end is for scientists to test out the services they have built. In the example here, we have created an AI model for image classification on the back end, and here on the front end we can upload an image to test out the effectiveness of the AI model. Go to the address linked here, select a project, a model, and a waiting file. Then lastly, you can choose an image to upload to test out the AI model you have just trained on the back end. The same is true for parallax estimation if you've trained an AI model for this purpose on the back end. Here on the front end, you just select a corresponding type of project, you select a model and a waiting file. Then lastly, for this to work, you have to select a right image and a left image to test out a parallax estimation. Lastly, we offer a manager module which will continue to build out for you to monitor all your projects. Visit this address and use this username and password to log in. Here you'll have an overview of all your projects as well as more detailed reports.